Good evening, my YouTube viewers. It's Crystal here. I'm making a video for you using Excel in this video. And what we're doing is we're covering the course material in the Alison course, Probability and Chances in Mathematics. And so what I've done is I'm taking all the course material and I've converted it to Excel. Now, if you looked at my previous three videos, we were going through the course material and probability and chance in mathematics, and I converted it to Python. So in this video, what we're doing is we're going to be doing the exact same work, but we're doing it in Excel instead of Python. The reason why I'm doing that is because I pay to get Excel every month, and since I'm paying for Excel, I may as well use it. So I'm going to use Excel as much as I possibly can to get my money's worth out of the program. So the first set of questions that we're going to discuss is about book combinations. So we have the question, how many combinations of books can you make in 8 books? So we've got the number of books is 8, and the number of combinations is equals factorial of 8. And that'll give you 40,320. And now we have how many combinations can 8 books make in 5 slots. So we have the number of slots is 5. And then what we do is we can't do a factorial in the strict sense, or not the way that I know to do it. But if you know a way that you can do it, then certainly, and you want to let me know, then certainly let me know. But the number of combinations is B3 times B3 minus 1 times B3 minus 2 times B3 minus 3 times B3 minus 4. And that gives you 6,720. So the next questions we have are going to be about dice. Okay, so the first question we have is, what is the mean of a fair 6-sided die? So your number of sides is 6, and the sum of the sides equals sum of 6, 5, 4, 3, 2, 1, which is 21, and the mean of the sides is B4 divided by B3, and that gives you a mean of 3.5. So that's the average number of a 6-sided die. And the next question that we have is, what is the probability of rolling 2 6s and 2 rolls of dice? So a probability of getting a 6 is 1 divided by 6. A probability of getting a not 6 is 5 divided by 6. And probability of getting 2 6s equals B9 times B9, which is 0.27778. So now we have the question, what is the probability of rolling 1 6 and 2 rolls of dice? So again, we have a probability of getting a 6 is 1 divided by 6. A probability of not 6 is 5 divided by 6. And a probability of getting 1 6 is B15 plus B16. No, sorry, B15 times B16 plus B15 times B16, which gives you 0.27778. And so I did go back and actually check this because I was worried that I thought it was a bit odd that it had the same value for 2 different questions. But when I checked it using a binomial distribution, which is another way that you can do it, it still came up with the same answer. So I'm satisfied that that's the answer to it. So now we have the question of a die tossed 3 times. What is the probability of no 5s turning up? And probability of not rolling a 5 in 1 toss. So number of tosses is 3. Probability of no 5 equals 5 divided by 6. And so the probability is B24 to the power of B23. And your answer is 0.578704. And so that's your probability in that instance. So now we're going to have some question concerning a deck of cards. So what is the probability of finding an ace or a spade in a deck of cards? So the probability of finding an ace is 4 divided by 52. The probability of finding a spade is 13 divided by 52. And then select an ace or a spade. So you have B3 plus B4 minus 1 divided by 52, and you have 0.307692. And you have to subtract 1 divided by 52 because a spade has an ace in it. So that's why you have to subtract. So it's not B3 plus B4, it's B3 plus B4 minus 1 divided by 52 because you have to take one of the cards out because an ace can also be a spade. The next question we have is talking about a coin and a dice. It said, what is the probability of finding a tail and a 2 in a coin and die? So probability of tail is 1 divided by 2. Probability by 2 is 1 divided by 6. Probability of tail and a 2 is B3 times B4, and so that's 0.08333. So the next question we have is with regard to schools. Or what I should really do is I should change this to chemistry. So it says there is a class of 30 students. 20 students study chemistry and 6 students study biology. 4 students study both chemistry and biology. Show the events of chemistry and biology are independent. So you've got your number. So what we're going to do is we're going to say chemistry. Just to identify this. A number of students is 30. Chemistry students equals 20. Biology students equals 6. And chemistry and biology equals 4. So probability of chemistry equals B8 divided by B7. So it's 0.6667. Probability of biology is B9 divided by B7. So that's 0.2. And probability of chemistry and biology is B10 divided by B7. So that's 0.13333. So the next question we have is going to be on humans. So choose one man from 3 men and 7 women. So one man is 3 divided by 10, and one woman is 7 divided by 10. And probability of one man is B3 times B4, so that's 0.21. So the next question we have is going to be about balls. So you have a bag of balls, which are 4 blue, 3 yellow, 2 pink. Probability of blue equals 4 divided by 9. Probability of yellow is 3 divided by 9. And a probability of pink is 2 divided by 9. So you have probability of selecting the same color twice. So 2 blue equals B3 times B3. So at 0.1975531. Probability of 2 yellow is B4 times B4. So it's 0.11111. Probability of 2 pink is B5 times B5, and it's 0.049383. So you have the probability of the same color is the sum of B9 to B11, which is 0.358025, and the probability of different colors equals 1 minus B13 is 0.641975. And you notice that these two numbers added together equals 1. So that's it for the question on fossils. So now I think what we're going to do is we're going to talk about Bayes' theorem. So you've got reverse probability is Bayes' theorem, and machines producing defective parts. So machine 1 is weighted at 0.6. Machine 2 is weighted at 0.4. Machine 1 with no defect is 95%. Machine 1 with a defect is 5%. Machine 2 with no defect is 92%. And machine 2 with a defect is 8%. So now we find the probability of a defect. Probability machine 1 defect equals B4 times B7. So that's 0.03. Probability of machine 2 defect equals B5 times B9, which is 0.032. Probability of machine 1 no defect equals B4 times B6, which is 0.57. And probability of machine 2 no defect is B5 times B8, which is 0.368. So now it asks the question, from 1,000 items, calculate the total of defective items. So the number of items is 1,000, and number of defective items is B20 times B13 plus B14. And so that's 62. And then it says, calculate the probability of defective items from machine 1. And probability of defective items from machine 1 equals B13 divided by B13 plus B14, and it's 0.483871. So that's your question about Bayes' theorem and machines. Now we have a question about disease. So what we're going to have is a true positive is individuals correctly identified as having disease. True negative is individuals correctly identified as not having disease. False positive is individuals correctly identified as having disease. False negative is individuals correctly identified as not having disease. So you've got your probability of disease is 0.02. Probability of not disease is 0.98. Sensitivity is 95%, and specificity is 96%. So now we calculate the true positive, false negative, true negative, and false positive. So your true positive is B8 times B6, gives you a value of 0.19. False negative is 1 minus B8 times B6. It gives you a value of 0.001. You have a true negative is B9 times B7 is 0.9408. And you have a false positive is 1 minus B9 times B7 is 0.30392. So you get asked the question, out of 10,000 people, the number of positive test results is. So the number of people is 10,000. Total positive is B20 times B13 plus B16. And then the true positive is B13 times B20. So the total positive is 582, but the true positive is 190. It says, what is the percentage of people who have disease? And B22 divided by 220 times 100. So it's 1.9% of people have the disease. Okay, so now the last question of this video is going to be about patterns. So we're going to check the probability of dice. So the probability of numbers 1 to 6 in the die equals 1 divided by 6, or 0.16667. So the total of that is 1 when you total all that out. So, and you can look at that. You can see. So you can see it sums to 1. So in the probability of weighted coins. So these coins are weighted. And so coin 0 is 0.25. Coin 1 is 0.5. Coin 2 is 0.25. And it gives you a total probability of 1. So that's just a question that we covered in patterns. So that concludes all of the questions that we covered in Module 1 of the course. And so I'm going to go ahead and conclude this video. The next video I make is we're going to cover the work that we did in Module 2. So if you like my video, please like and subscribe. And I look forward to communicating with you in the next video.